In this clip, we'll talk about exponential functions. Exponential functions can be written of the form of f of x is equal to c, being c is just any constant or real number, times a raised to the x. Typically, exponential functions, a is also a real number, and it makes it exponential when the function of x becomes the exponent. As you can see written there, when a is greater than 0, a is called a growth factor, where c is like your initial value because it's a constant. And in an exponential function, the ratio of f of x plus 1 and f of x is like a constant ratio. So you should be able to define or find the growth factor by taking the function f of x plus 1 and dividing it by f of x. That makes sense because if I evaluated this further, this really is just saying c of a to the x plus 1 over c a to the x. It's like c cancel, and then this is a to the x plus 1 divided by a to the x, which just leaves me with a. So that's just all that means. So some properties about the graph and evolution of an exponential function. Remember, exponential functions are of this form. When you have a is greater than 0, we call this a growth factor, where it just grows exponentially at a normal rate. The domain for these functions is all real numbers, so it goes between negative infinity and infinity. The range, however, is only positive numbers from 0 to infinity. As we denoted with calling it the growth factor, when a is greater than 1, then it's increasing on the whole domain. Whereas when a is less than 1, it's not increasing, it's decreasing or never increasing. These two properties flip. When a is less than 1, then suddenly this becomes increasing on the domain, when this is never increasing or never decreasing on the domain. This is decreasing, sorry, not increasing. This is decreasing on the domain. This is never decreasing on the domain. Y-intercepts are both the same, being 0, 1. And the horizontal asymptote is still the x-axis, being y equals 0. So what does that look like as a graph? It's something like this. Here, a is always positive, and we are growing and increasing exponentially upward. Here, a is anything less than 1, and we are decreasing on the domain. Well, actually, no, this isn't even that. This is just an inverse function of an e to the x. So the inverse of e to the x is e to the negative x, which is the same thing as 1 over e to the x. And 1 over e to the x is a reflection of the graph across the y-axis. And our y-intercept still being 0, 1, and our asymptote being the x-axis, or y equals 0. It's good to familiarize with yourself with how exponential functions look, because oftentimes you'll be asked to graph or evaluate exponential functions or derive the function from the graph, and you'll just have to know like what type of graph it is, or how to draw it if you're asked to draw it, type of stuff. So it's definitely some good knowledge to know.